Hi guys, I am Divyan from IGCSE on Fingertips, and today we are going to solve chemistry paper 2 of Feb-March 2020. Let's get started. A student investigates a pendulum. He measures the time for the pendulum to complete 20 oscillations. He repeats the experiments 3 more times. The readings are shown. Experiment 1, 2, 3, 4 and oscillation for 20 oscillations. You might notice guys, the quality of this page is not up to what we generally have, right? This is because this is a scanned page. We got it from Reddit and this is the best copy available. So please try to zoom in and read. We will keep the link of the paper in the description below, right? So coming back to the question, 20 oscillations is taking 17, 19, 17.6 and 18.6 seconds, right? What is the average period of the pendulum? What is average period? The time period, right? So the first thing I will do is I will add them all, correct? Because I want to find the average. So 17.6 plus 19.8 plus 17.6 plus 18.6, which will give me 73.6, and this is the oscillation for 20 and 4 times, right? So first I will divide by 4. This is 18.4 is the average time for 20 oscillations, and divide by 20 will give me the average time for one oscillation, right? Time period is one oscillation. So option B is your correct answer. A tennis ball falls from the upstairs window of a house. What can be said about the acceleration of the ball if air resistance is ignored? If the air resistance is ignored, acceleration of the ball is constant. It depends on density of the ball? No. It depends on the mass of the ball? No. It increases as the ball falls? No. It stays the same as the ball falls. So D is your correct answer, right? Gravity acts on everything equally, right? Gravitational acceleration acts on everything equally. So no matter what the mass, what the density, if air resistance is ignored, it stays the same. A car joins a road at a speed of 14 meters per second and accelerates at 4 meters per second square for 5 seconds. What is the final speed of the car? We will simply use the formula V is equal to U plus AT. You have final velocity we have to find, but the initial is given as 14, acceleration is given as 4 and time is given as 5. So 14 plus 20, 34 meters per second, which is option D. Option D is your correct answer. Question number 4. The gravitational field strength is 8.8 Newton per kilogram on Venus and 3.8 Newton per kilogram on Mars. This Newton per kilogram, guys, is nothing but equivalent to meters per second square. This is an equivalent to meters per second square. So this is nothing but the gravitational acceleration. An object has a weight of 42 Newton on Venus. What is the mass and the weight of the object on Mars? So if 8.8 Newton, the object that has weight of 8.8 Newton, has a mass of 1 kg. What is the mass if 42 Newton is its weight? So what we have to do? We have to divide simply 42 divided by 8.8. So you get 4.77, right? I get 4.77 here. Now 4.77, okay, we don't have an option, but we have 4.8 as an option for the mass, right? Let's find out what is the weight. If 4.77 is the mass multiplied by the gravitational acceleration, so I'll take 3.8, which gives me 18.136, right? This means that my answer is 4.8 is the weight, 18.136 is the mass. So rounding off, option A is the correct answer. Now, question number 5. A student carries out an experiment to find the density of a rock. Which two measurements does the student need to determine the density of the rock? Measurement 1 increase in mass, measurement 2 increase in volume, right? Because the rock's volume is increase in volume and the mass is also increase in mass, right? Initial, final minus initial in both the cases. So we are finding change and this change is actually increase. So option A is the correct answer. Okay. Let's look at question number 6. We have a car has a mass of 1500 kg. A constant resultant force acts on the car and the car accelerates from 15 to 20 in 4 seconds. What is the magnitude of resultant force acting on the car? The force is responsible for causing this acceleration, right? So what I'll take, that force is equal to mass into acceleration. What is the acceleration? I'll write 1500 into acceleration. Acceleration is 20 minus 15 upon 4, right? This is the resultant force on the car. So 1500 multiplied by 5 divided by 4, 1875. But we don't have an option of 1875, but we do have 1900. This is the closest answer, right? 1875 is closest to 1900. Sometimes you do have to take the round off, right? 1900 Newton. Also because this is significant to two figures, 2, 2 and 2. So your answer should be rounded off to two significant figures. Let's look at question number 7. A metal wire is loaded up to the limit of proportionality. Which statement is correct? Hooke's law is not obeyed when the load is increased from 0 to this point. No, Hooke's law is obeyed because it is loaded only up to the limit of proportionality. When the load is increased beyond the limit of proportionality, the diameter of the wire will increase. No, the diameter of the wire will decrease because the wire starts stretching. When the load is removed, the wire returns to its original length. Yes, it does, because it is only loaded up to its limit of proportionality. And up to the limit of proportionality, there is no change in the shape of the wire. There is a change, but this change is directly proportional to the load. That is what Hooke's law is. So our option C is the correct answer. Question 8. The diagram shows a uniform meter rule Mn pivoted at its midpoint P. Two weights W1 and W2 are hung on either side of the pivot. The rule remains balanced. Which row is correct? If it remains balanced, then the clockwise moment and anti-clockwise moment are equal and therefore net moment is 0. If it remains balanced, if it's not going down or going up, the net force is also 0. In other words, this particular rule is in equilibrium. For equilibrium, two things are compulsory. The net moment must be 0 and the net force must be 0, right? So direction of resultant moment about the point M is 0 and direction of resultant force on the rule must be 0. Otherwise, this will not be an equilibrium. So option D is the correct answer. Question number 9. Which physical quantity is a vector? Mass? No. Density? No. Temperature? No. And velocity? Yes. Okay. Next question. A resultant force of 500 Newton acts for 10 seconds on car of mass 1000 kg. This causes the velocity of the car to double. So let's write down the given value. You have force is equal to 500 Newton. You have time is 10 seconds and let's take velocity is equal to v, right? It doubles. So shall I write here that u, the initial velocity is v and the final velocity is twice, right? 2 times of v. So they are asking what is the final velocity of the car. Now from this understanding I can write F is equal to m into v minus u upon t, correct? The mass of the car is 1000 kg. That is also given to us. So let's do this. So you have 5000 is equal to 500 multiplied by 2v minus v is v upon time is 10 seconds. So 0, 0 gets cancelled, 50, 100 times, right? 0, 0 get cancelled and 500 times. Yes, it is 100 times. So you get 100 is equal to V. Sorry. I've taken this as 5,000 here. So let's just quickly do this again, right? So we have 500 is equal to 1,000 kilogram, right? Into V minus U, which is V, right? 2V minus V is V, and time is 10 seconds. 1 get cancelled, 0, 0, 0, 0, and 5. So your V is 5. But what do you have to find? You have to find the final velocity, which is 2V, right? It should be 5 into 2, 10. So your answer must be B, 10 meters per second. Let's go to the next question we have. A child pushes a toy car along the horizontal surface and then releases it. As the car slows down, what is the main energy transfer? First understand that when the horizontal surface, when the car is released, it slowly comes to rest because of frictional force, right? So frictional force will generate heat. If nothing else, it will dissipate this energy in the form of heat. So as the car slows down, when it slows down, it must have kinetic energy, right? It must start with kinetic energy. What is the main energy transfer? It's going from kinetic because it's in motion. So it has kinetic energy and goes to heat energy, right? Because friction causes heating. It is dissipating this energy in the form of heat. Let's find out an answer that matches this. Chemical to thermal? No. Chemical to kinetic? No. Kinetic to gravitational? No, because it's horizontal surface. And from chemical to thermal, yes, heat energy is nothing but thermal energy, right? It's the same. Different name, same effect. Okay, then we have 12th question. Yes. So at time 0, a cannonball is stationary inside a cannon. The cannonball is then fired from the cannon. At time t, the cannonball moves forward and the cannon moves backwards. What happens to the total kinetic energy and the total momentum of the cannon and the cannonball between time t is equal to 0 and time t? Now if you observe, let's say this is the point, right? Cannonball goes forward and the cannon itself goes backward. Now, according to the law of conservation of momentum, correct? What must happen is that whatever momentum the cannon itself has when going backward is equal to the cannonball's momentum going forward, right? But cannon must be much heavier than the cannonball. So cannon itself will go with a lesser velocity compared to the cannonball, right? So the momentum remains same. Total momentum remains same. So I will not consider option A and C for my answer, right? Now what happens to the total kinetic energy? Now see, the cannonball is thrown, right? It's bombarded, it's thrown with the help of some explosive, right? Some force that uses energy. So the kinetic energy is increasing because energy is coming from somewhere else, right? From the blast. So the kinetic energy, total kinetic energy of both of them increases. On top of that, kinetic energy is not a vector. So in case of momentum, the forward and backward momentum get cancelled out, but kinetic energy gets added up because it's not a vector. So I will say total kinetic energy changes and the total momentum remains same. Option B. Question number 13. A small hydroelectric power scheme, 800 kg of water drops to a vertical height of 2.2 meter every second. The electrical output is 10.6 kilowatt. What is the efficiency of the scheme? Okay, so just starting from back, right? What do we have to find? We have to find the efficiency. Efficiency is nothing but output. Let me write it somewhere else. So we have space for our working. So energy is, so efficiency is output upon input into 100. Output is already given 10.6 kilowatt. Let's find input. Input is nothing but the change in potential energy. Potential energy is mgh, right? This should be 800 falls to a vertical height of 2.2 meter, right? And every second. So 2.2 meter every second, so this will become 1, and therefore joules per second becomes power, right? And we will take this as 10, right? The gravity is at 10. So 800 into 2.2 into 10, I get 17,600. So I will get 17.6 kilowatt. If 17.6 kilowatt is the input and 10.6 is the output, let's quickly find out. 10,600 divided by my answer into 100. This gives me 60.22727273. Right? So my option C is the correct answer. Okay? 60% is the efficiency, not 0.6. If you don't multiply this 100, you will get 0.6, and that's not the correct answer. 0.6 is the efficiency. 0.6% is not. Right? Next question. An object is at rest on a horizontal surface. Which equation is used to calculate pressure that the object exerts? This is nothing but the formula of pressure. Mass of the object upon area of contact. No, it's force upon area, right? Force is weight of the object upon area of contact. So B is the correct answer, right? Then we have question number 15. Smoke particles illuminated by a bright lamp are seen through a microscope. Okay? They move about randomly. What causes this motion? The smoke particles are being hit by air particles which have Brownian motion. So attraction between smoke particle and molecule of air. Okay? Is there attraction or collision? Collision between smoke particle and the molecule of air will be the correct answer, right? Because there is collision and they start to go in opposite direction after the collision. This causes the illumination, right? This causes the random motion. Next question. Ether is a liquid that evaporates easily at room temperature. A rate at which ether evaporates can be increased by bubbling air through it. The diagram shows this process, okay? They are adding air, bubbling it through ether and hoping that more ether will get evaporated. Students give 3 suggestions why the rate of evaporation increases when air is bubbled through. Student 1 suggests that the temperature of ether is decreased. Now evaporation can take place at any temperature, but the higher the temperature, more the evaporation. Right? So student 1 does not seem to be correct. Right? Student 2 suggests that the surface area of ether has increased. Yes, indeed that has happened because the bubble around the bubble, whatever ether particles are there, they can evaporate. They can go inside this bubble in the form of vapor. So the surface area has technically increased. And student 3 suggests that evaporated molecules are removed at a greater rate. Yes, because the air bubbles are being passed through. They are continuously removed as well. So which student is correct? Student 1 is wrong, but student 2 and 3, both of them are correct. So I will check the answer C. Let's go for the next question. Question 17. Some ice is slowly heated and its temperature is measured. A graph is plotted of the temperature against time. Which row describes what happens to thermal energy and to the temperature in section X? The temperature remains constant. This is melting, right? At 0 degree, the ice melts. But it is continuously gaining heat. It is using this heat to break the intermolecular forces, right? Break away from the intermolecular forces. So let's find out. Thermal energy is gained by ice, but the temperature remains same. So option B. Then we have question number 18. A diagram shows the apparatus needed for an experiment to determine the specific heat capacity of material from which an object is made. Okay. So which piece of apparatus could be omitted if the purpose of experiment is to determine the thermal capacity? Now see, first they are trying to find the specific heat capacity. Let's focus on units. Specific heat capacity has a unit of joule per kilogram, degree Celsius or Kelvin, right? But the thermal capacity has a unit of joule per degree Celsius, right? So what happens is, for example, 1 kilogram of ice or 1 kilogram of water will have specific heat capacity, okay, per kilogram. If I find out the heat capacity per kilogram, that is specific heat capacity. If I find out, if I take a water body, right, if I take water in beaker and then find out its thermal capacity, the heat needed for me to raise its temperature by 1 degree Celsius without understanding what is its mass, right? So that will become joules per degree Celsius. So what do you need to remove? You don't need to measure its weight. Everything else remains same. If you don't measure its weight, you will be finding its thermal capacity. So how do you remove this? You remove balance. Okay. Then we have question number 19. Both boiling and evaporation involve a change of state from liquid to gas. Which gives the correct difference between boiling and evaporation? Let's see. No bubbles are formed. No. In boiling, bubbles are formed. So let's cancel this. Occurs at all temperature? No. Occurs throughout the liquid? Yes. And in boiling, the temperature falls? No. The temperature actually stays the same, right? While boiling, the temperature stays the same. You just seen in a couple of questions ago. Evaporation, bubbles are formed? No. Occurs at definite temperature? No. Occurs at surface only? Yes. And the temperature remains constant? No. It may change, right? It causes cooling. Evaporation causes cooling, so the temperature falls. And therefore, the correct answer is option C. Question number 20. Which statement describes thermal conduction in a metal by electrons? Atoms and electrons move freely throughout the metal? No. Only electrons can. Atoms and electrons vibrate about their fixed position only? No. Electrons can move. Electrons move freely throughout the metal? Yes, that is the correct answer. So, it is definitely because of the vibration of atoms, but the first two statements give a factually incorrect statement. Okay, here it says atoms move freely. No, it does not. Here it says electrons vibrate about their fixed position. No, electrons can move. Therefore, C is the correct option. Right? A better answer for you to write in your paper 4 regarding these type of question is electrons can move freely and atoms vibrate in their fixed position, at their fixed position. Question 21. A tank contains water. Ripples are produced on the surface of the water. Refraction is observed. What causes the ripples to refract? Okay, refraction is when the depth of this water tank changes. The cold water in the tank is replaced by warm water. No, you are observing refraction, right? Ripples change speed as they move from deep to shallow water. Yes. The ripples hit the wall of the tank, it will cause reflection. The ripple pass through a narrow gap causes diffraction, right? Only option B says how does refraction takes place. Okay. Question number 22. The diagram shows wavefronts of water wave passing through a gap in the barrier. Which change will increase the diffraction of waves as it passes through the gap. Increase the amplitude of water, nothing will happen. Increase the width of the gap. Okay? If you want to increase the diffraction, increasing the width of the gap won't help. Reduce the width of the gap, yes, you reduce the width of the gap so that what happens is these diffractions take place more, right? When the gap is almost equal to the wavelength of the wave. So reduce the depth of water, reduce the frequency of wave. So you can't increase. Okay, reduce the depth of water and reduce the frequency of wave. I think I read it. Reduce the width of the gap. I read it incorrect. Let's see. Reduce the depth of water. No, that will only cause what do you call it? Refraction, right? Just we understood. Reduce the frequency of water. Now by the equation V is equal to F lambda, right? If you reduce the frequency, the wavelength must increase because velocity of water in this particular depth is fixed, right? So when you reduce the frequency, wavelength increases and you can go on increasing the wavelength until unless this gap and the wavelength are equal. And therefore I will go with answer D. Reduce the frequency of the wave. If you reduce the depth of the water, it does not change, right? Question 23. Let's see what do we have. Okay. The diagram each show a tray passing through a thin converging lens. Principal focuses in each diagram are labeled F. Which diagrams are correct? Okay, let's focus at the diagram. In part 1, the diagram, the ray passes through the center, right? The center of the lens, and it must pass through unrefracted, right? In the second one, after refraction, the ray must pass through the focus. This does not. So 2 is definitely incorrect. And in third one, after passing through the focus, right, as if the ray had started from focus, if it passes through the lens, it becomes parallel to the principal axis, which is correct. So 1 and 3 are correct, and your option C is the answer. Let's go to the next question, question number 24. We have the diagram shows a ray of light inside an optical fiber approaching point X. The light is totally reflected within the fiber. The refractive index of material of the optic fiber is 1.39. Which condition ensures that the total internal reflection occurs? For total internal reflection to occur, let's find the critical angle first, right? So n is equal to 1 upon sine c, right? And therefore c is equal to 1 by n and the whole thing sine inverse, right? Let us do 1 divided by 1.39 and then sine inverse of this answer gives me 46. So the critical angle for this particular material is 46.0069 degrees. Okay. Now, which condition ensures that total internal reflection occurs? If your Q is greater, than C, right? Total internal reflection will take place. So C is 46. So Q is less than 45? No. Q is greater than 47? Yes. If Q is greater than 47, total internal reflection will take place. So that's your answer. Let's see the next question you have. Question 25. Okay. Just a second. Yeah. Okay. 25. An eclipse of sun happens when moon comes between Earth and the sun. Which statement is correct? Infrared radiation from sun disappears before visible light and ultraviolet light. Okay. Ultraviolet radiation from the sun disappear before visible light and infrared. Okay. Visible light from the sun disappears before ultraviolet and infrared. Infraradiation, ultraviolet radiation and visible light from the sun or all disappear at the same time. Now see guys, as far as I understand this, they are trying to get you confused, right? Because infrared radiation, visible radiation and ultraviolet radiation all are electromagnetic radiation coming from the sun, correct? Now, if something is coming between you and the source of light, no matter what kind of radiation it gives, right? All of them get blocked, as simple as that. So, infrared, ultraviolet and visible from the sun all disappear at the same moment, right? The diffraction here can't be seen, right? There is no slit. So, I will go with option B, right? Question number 26. Diagram shows air particles in a sound wave. Okay. V, W, X, Y, and Z. Which row correctly identifies position of compression and position of rarefaction? Even without looking at options, Y and W is rarefaction. V, I can't say V for sure, but X and Z, right? These are compression. Let's go for it. Rarefaction, Y, there is no W, so it has to be Y, and compression X. So option A is my correct answer, right? Only available answer is option A. Okay, question 27. Two isolated metal spheres are both negatively charged. The spheres are brought close together but do not touch. Which diagram shows the charge distribution on the spheres? Now, in the first one, negative charges are close to each other, not possible. In the second one, whoever has given this paper, they have drawn that positive charges are here, right? So the charge distribution changes. I believe that is also incorrect. So both B and C are similar, right? The charge distribution change. So B and C, both of them are incorrect. But in D, if you observe, the negative charges are repelling each other, and that's true. So I will take answer D. Then we have question 28. Two separate circuits have different power supplies. Okay. Both power supplies provide the same magnitude of current. So the current I is same. Power supply P has an EMF of 1.5 volt and power supply Q has an EMF of 3 volt. Which statement about Q are correct when compared with P? Q supplies twice the charge per unit time. Now we don't know that because they have different power supplies, right? And they have same magnitude of current. If they have same magnitude of current, twice the charge per unit time? No, not possible, right? Current is charge per unit time, and that's same. Okay. Then we have Q supplies twice the energy per unit charge. Let the current be I, right? For P, let's find out what is its power. Power is nothing but V into I. So 1.5 times of I is the power of P and 3 times of I is the power of Q. So Q supplies twice the energy per unit charge. This is correct, right? Twice the energy. It has power is nothing but energy per second. Q supplies twice the energy per unit time. This is also correct. So option 2 and 3, right? Answer D is the correct one. Let's look at the next question. The diagram shows a piece of metal resistance wire. Which wire made of same material has the smaller resistance? A wire of the same length and larger diameter. First of all, let's break it down to resistance is equal to rho L upon A. Rho is nothing but the resistivity. If both of the metals are same, the resistivity is same. So if longer length, more resistance. If larger cross-sectional area, lesser resistance. So wire of same length with larger diameter, larger cross-sectional area, so it has smaller resistance, right? So this is the correct. But why are others incorrect? Let's have a look. A wire of same length with a smaller diameter, again if the diameter is smaller, the radius must be, the resistance must be larger. A wire of greater length, if the length is greater, the resistance is greater. A wire of greater length, again, length greater, resistance greater. Now, this is a conflicting answer. This is a conflicting answer. Greater length with same diameter, right? Okay, no, it's not conflicting, my mistake. Okay, that's it. Let's go to the next question. Question 30. Which labeled component in the circuit shown controls the brightness of lamp X? So if you change the resistance of V, the voltage distribution between X and V changes, and therefore V controls the brightness of the lamp, right? A measures the voltage across these two, right? And the voltage, because this arrangement, right? This arrangement and this arrangement, they are in parallel connection. The voltage across both of them is equal, and therefore this does not have any effect on the voltage in this branch. Therefore, my answer is B. Next question. A circuit includes a battery. Just a second. And this may not be visible, so please download the paper for this question specially. Hopefully, when you see this video, there will be official papers out, so you can refer to that also. A circuit includes a battery, two identical resistors, and 5 ammeters P, Q, R, S, and T. Which statement about the readings on the ammeter is not correct? Okay, this is P, Q, R with resistance, S and T with the same resistance. P has a, which is them is not correct, okay? P has a greater reading than Q. No, both will have the same reading, right? The number of electrons going out from here will again return here. So the first statement itself is incorrect, right? That's our answer. Let's see the next question. We have question 32. An electrician sets up a potential divider circuit in a fridge so that when fridge door is open, the light from the room enters the fridge a warning light turns on. Which component does the electrician need to use in addition to variable resistor? So he wants to detect the presence of light. He must use light dependent resistor, right? That's it. Then two NAND gates are joined together as shown. Which basic single logic gate is equivalent to the combination? Now, see, negative of a negative is positive, right? In the same way, if you go through NAND gate twice, it becomes an AND gate, right? So your answer is option A. You can use the inputs 1, 1, 1, 0, 0, 1 and 1, 1 to find out if this matches the AND gate or not, right? Then we have the next question. We have, okay, there's a diagram. The diagram shows an electrical drill and safety guard. The drill requires logic circuit shown. Let's look at this circuit. Okay. Starting switch on off, safety guard open close, and there is motor and alarm. The circuit must only allow the motor to start when the safety guard is closed. Okay. So this works with only one, right? And this has to be an AND gate, multiplication gate, because motor turns on only when there is 1 in the input. If, just a second, if the safety guard is not closed when starting the switch, then when the starting switch is on, the alarm must sound. Okay? Let's see how to handle that. So this gate must be something that when 1 comes from here and 0 comes from here, the alarm is on. So we need the output 1. Okay? So when safety is closed, this is a NOT gate, right? So this gives 1 output. Okay? And when it is open, right, we need to change this a little bit. Okay? Just a second, guys. So we need to change this a little bit. When the output from here is 1 and when the output from here is 1, the alarm must sound, right? 1 output gives 1 with an AND gate, right? If either of them is 0, the answer becomes 0. If both of them are 0, the answer becomes 0, right? So if I need 1 and 1, the answer is AND gate again. So I will take the answer AND gate. Then we have 35. Two magnets are placed near a current carrying conductor coil. The diagram shows this experimental arrangement and the circuit direction in the coil. Which statement is correct? Okay. Both X and Y are attracted to the coil. Okay. So what we need to see, on the left arm of the coil, the current is going like this, right? What direction is this? This is clockwise direction. Let's see, in clockwise direction, you are facing the south pole. So this south will not be attracted to this south. If this is the south pole, this has to be the north pole. Let's just, if you're looking from this direction, this is the north pole, right? And therefore, this will also repel. Both X and Y are attracted to the coil, or both X and Y are repelled by the coil. Both X and Y are repelled by the coil. Okay, then let's see what we have next. Okay, we have a better page at least. Two circuits are set up as shown. The iron rods are placed close together and are able to move. What happens to the size of the gap when the switch S is closed? Okay, so in this, let's say, goes plus minus, right? So the current here is in this direction, right? The current here is in this direction, which is south pole, right? Clockwise, we just did it, south pole. For this one, the current here is in this direction, right? It's going from bottom and starting up, right? This is also in same direction, right? So the gap must increase because both of them are south pole, and south poles repel each other, like poles repel each other. So it increases, option C, right? The gap increases. Question number 37. When a current carrying conductor is placed in a magnetic field, it experiences a force. Which statement about this force is correct? It is parallel. Okay. When a current carrying conductor is placed in a magnetic field, it experiences a force. This is nothing but a motor. Motor uses left hand rule. So all three are perpendicular to each other. Just remember that. It's parallel to both magnetic field and direction of current? No. It's parallel to magnetic field and perpendicular to the direction of current? No. Perpendicular and parallel? No. It is perpendicular to both magnetic field and the direction of current. This is the correct statement. Question number 38. When a beam of alpha particles is incident on a thin metal foil, most of them follow a path represented by path X in the diagram. A small number of alpha particles follow a path represented by path Y in the diagram. So most of them this, some of them this path, right? It may appear bent, but it is a straight line. Okay? This is a straight line like this, appears bent due to the bent in paper. And this is reflected like this. Which row correctly describes a conclusion that can be drawn from each of these observations? Most of them passes, so most of the atom is empty, and this is reflected, so the center of atom is small and is positively charged, right? So path X, atom is mostly empty, yes. And path Y, atom contains something that repels the alpha particles. Okay? So option A is the correct answer. Question 29. Nuclear fusion is a reaction that takes place in stars. Which row describes this reaction? Action of atomic nuclei. In stars, two lighter nuclei fuse together to form a heavier nuclei. An atomic nucleus splits, okay, join together to form a larger nucleus. And all over energy is released. Okay, this reaction does require energy to start, but the net change in energy is output. Okay, energy is given out. So option D is your correct answer. Now we have the last question of this paper, question number 40. Okay. Right. Then when a radioactive isotope is set up close to a counter, a count rate of 38,000 counts per second is obtained. The table shows the count rate from the isotope over a 3-year period. What is the half-life of isotope? Let's check. So first you have count rate of 38,000. It becomes half. So 38,000 divided by 2 will give you, just a second please, 38,000 divided by 2 will give you 19,000. Correct? So does it become 19,000 in 1 year? No, it does not. It becomes 19,000 in between first and second year, somewhere here. Right? Now just for the sake of understanding, because what is the half-life? Less than 1 year? No, it's greater than 1 year, less than 2 years. More than 1 but less than 2. Now what if it's 1.5? Right? Because we have third year also. So let's check that also. What I'll do? I'll divide 19,000. Okay, let me take a. Okay, so I'll divide 19,000 by 2, and therefore 15 divided by 2 is 8.5. Sorry, 9.5. So 9,500. If your half-life was 3 years, the count rate at the end of third year would be 9,500. But it's not. It's 12,000. Right? So it's between 1.5 year and 2 years. Okay. So more than 1 year, but less than 2 year. More than 2 year, no. Only option B is the correct answer. And with this, we have finished this paper. Thank you for watching, guys, and all the best for your exams. Do return for more videos. If you enjoy our videos, comment, like, share, and subscribe.